Welcome to Creating Effective Tables. In this video, I'll go over some of the elements of an effective table. My name is Joe Munch, and I'm part of Editing Services in MD Anderson's Research Medical Library. Here are some considerations for organizing data in a table. Place the data to be compared adjacent to each other, ideally side by side. Typically, independent variables are used as row headings, and dependent variables are used as column headings. Arrange the data in logical order. So, for example, all demographic data are provided, and then all treatment data are provided. Sometimes you'll have to depart from these general guidelines because of space constraints. For example, the width of the page limits the number of columns you can have. But consider as you design your tables what readers will be looking for and how to make it easy to find that information. Next, we'll look at examples of ineffectively and effectively formatted tables and talk about how to format tables to maximize their clarity. First, let's look at a pair of examples that focus on the organization of the data. This is a table describing tumor recurrences according to the radiation therapy doses received. Let's say we want to compare how many patients in each dose group had 3 or more recurrences. Where is that information? This information is somewhat buried in the table. 3 or more recurrences were seen in 4 patients of the 107 patients in the low dose group and 4 patients of the 139 patients in the higher dose group. But readers have to work harder than is necessary to find and compare these numbers. One clue that this is an ineffectively designed table is the number of empty cells you see in the first 2 columns. In contrast, here are the same data in a table with the 2 doses as column headings instead of row headings. Now, it's easy to compare the numbers of patients in each group who had more than 3 recurrences because the numbers are side by side. Also, the total numbers of patients used to calculate the percentages are easily found in the column headings. Ideally, the information to be compared should be arranged horizontally in adjacent columns because in English, we are used to scanning a page from left to right and then vertically from top to bottom. This is another ineffective table. First, some general comments. The table has some design issues that detract from its data presentation. The blue shading does little to help delineate information in the table. If anything, it obscures the text, making the table more difficult to read. In addition, contrary to the table design guidelines of the AMA and those of most journals, vertical lines are used. Other details or lack thereof create confusion. Glaringly, there's no table title to indicate what the table shows. Abbreviations are not defined. P-values, shown in the rightmost column, are given for only some variables without explanation. But what contributes most to the ineffectiveness of this table is probably the way in which information is presented in the row headings and the column headings. Among the row headings in the characteristic column, there is no indication of whether or how these characteristics should be grouped, and this can create confusion. Adding to that, some row headings seem to be missing and others are totally ambiguous. As for the column headings, they are inconsistent in the way in which they indicate the types of data shown below. The second and third column headings list the percentage and the total number of patients in the group, but the fourth column heading lacks the percentage sign. The actual data in all 3 columns are percentages with numbers of patients in parentheses, but that is not clear from the column headings. In sum, this is an ineffective table because its design and organization make it difficult for readers to quickly access and understand the data presented. Here are the same data presented in an effective table constructed following AMA guidelines. No vertical lines or shading is used, making the table easier to read. A title clearly indicates what data the table includes. Abbreviations are defined. We can now easily see that IQR stands for interquartile range. All p-values are given. Bold italicized text is used to draw attention to the significant values. But most importantly, the row headings and column headings are clear, consistent, and organized. The row headings in the characteristic column are organized and complete. Indentations are used to clarify how these characteristics are grouped, and amended or additional row headings provide a full picture of what characteristics are included. The column headings are consistent in the way in which they indicate the types of data shown. And a straddle heading over the second through fourth columns clearly indicates that the data are given as the number of patients percentage. The accompanying footnote clarifies that this is the case unless otherwise specified. Shown side by side, it's easy to see which table provides clear, complete information. Here's another ineffective table. This table is hard to understand. What information is it meant to convey? We have some clues. The title indicates that the table is showing the results of univariable and multivariable analyses. The column headings indicate that groups are being compared using statistical tests. And the row headings indicate that the analysis was about patients who underwent cancer treatment. But it's hard to figure out exactly what this table is meant to tell us. The clarity of this table could be greatly improved through better labeling and alignment. In this revised version of the same table, we've expanded the title, and we've added column headings. Those two changes greatly improve the clarity of the table. Now we can see that the table is about predictors of recurrence. Rates of recurrence are being compared between different subgroups of patients. However, the data are still a bit hard to understand because they're very spread out, and not all data align with the correct row headings. In this revised version of the same table, we have merged some columns. The number of patients and percentage of patients now appear together, and so do the odds ratios and their 95% confidence intervals. Placing closely related values next to one another makes the table easier to read. In the row headings, we have moved the subgroup names like male and female under the group names like sex. Similar to what we see with the column alignment, placing the group and subgroup names near one another makes the table easier to understand and read. We have also added a new row at the beginning of the table, all patients. The information in this row provides some useful context in which to interpret the other information in the table. In this revised version of the same table, we have specified the units in the age and time categories, years and days, respectively. We've also defined the abbreviation NA, which means not applicable, and added a footnote to explain what the asterisks in the row headings mean. This additional information further clarifies the information in the table. One additional point, we recommend not leaving cells empty. If a cell is left empty, readers could think that it was left empty by accident. In the analysis reported in this table, variables were entered in the multivariable analysis only if the p-value on univariable analysis was less than 0.1. For the variables not entered in the multivariable analysis, we have typed NA in the multivariable analysis columns. It would also be correct to use a long dash or ellipses in place of NA. Here's the final table. The main message of the table is now easy to grasp within a few seconds. We can quickly see that only one factor was significantly associated with recurrence on univariable and multivariable analysis. That's mutant RAS. Thanks for viewing this video on the elements of an effective table. For further information about scientific writing and publishing, or to request editing or a consultation with an editor, check out these resources from the Research Medical Library.